Welcome to the course on Python for data analytics, machine learning and generative AI. In this video, we are going to learn about functions in Python, a practical guide to reusable, flexible and powerful Python code. In this video, we will cover why functions are important, basics of Python functions, different types of function arguments, handling variable, number of inputs, combining all arguments, types of function scope, decorator, generator, and memory efficiency and specialist function tools. By the end of this course, you will understand Python function clearly and be able to write your own functions and know how to pass values and get results from functions. A function in Python is a reusable block of code that performs a specific task. Instead of writing the same code again and again, we can place it inside a function and use it whenever required. This makes our programs shorter, cleaner and easier to understand. Let us begin by understanding a very common problem in programming, repetition. Let's see the code written to calculate the area of two rectangles. For rectangle 1, we define length and width, calculate the area and print it. For rectangle 2, we repeat the same logic again with different values. This approach works, but it creates repetitive codes. If we need to calculate the area for many rectangles, our program will become long and difficult to manage. Also, if we want to change the formula later, we must update it in many places. Instead of repeating the same code, we create a function called calculate of area. The function takes length and width as input, calculates the area and prints the results. Now, whenever we need the area, we simply call the function with different values. This makes the code shorter, cleaner and reusable. The keyword def tells Python that we are starting the definition of a function. Every Python function must begin with def. Here we see the function names greet_user followed by parenthesis. Inside this parenthesis, we have name. This is called a parameter. A parameter is a placeholder that will receive a value later when the function is called. Inside the function, we create a message using the parameter name. Then we use the return statement. The return keyword sends the result back to the place where the function was called. In the function call, we call the function and pass the value ml. This value is called an argument. An argument is the real data sent to the function. So remember this clearly. The parameter is written in the function definition and the argument is the value passed during the function call. There are three important argument types. First, positional argument. In positional arguments, values are assigned based on their order. The function name age expects name first and age second. When we call the function as name age of Suraj, 27, Python assigns Suraj to name and 27 to age because of the position. This method is simple, but it can become confusing if you forget the correct order. Next, keyword arguments. Here, we pass values by explicitly mentioning the parameter name. We call the function using fname and lname. Even though the order is changed, Python correctly matches the values using the parameter names. Finally, default arguments. A default argument has a value already assigned in the function definition. In the example, the parameter y has a default value of 50. When we call the function with only one value, Python automatically uses the default value of y. By default, when we create a function in Python, we must call it with the exact number of arguments that the function expects. For example, if a function is defined to take two values, then we must pass only two values while calling it. For sum of 1, 2, this works perfectly because the function sum of a, b is designed to accept two arguments. So Python executes the function successfully and we get the correct result. This is why we see the success mark. Now for sum of 1, 2, 3, 4, here we are passing 4 values. But the function definition still expects only 2 arguments. Because of this mismatch, Python throws an error called a type error. The error message clearly says that the function takes 2 positional arguments but 4 were given. This situation creates a problem. What if we want to write a function that can add 2 numbers or 5 numbers or even 100 numbers? Do we need to write separate function every time? The answer is no. Python gives us very useful and flexible solution for this problem by providing 2 special tools. Asterisk args for handling a variable number of positional arguments and double asterisk kwargs for handling a variable number of keyword arguments. Using these tools, we can write functions that do not care how many inputs are passed. When we add a star before a parameter name, Python automatically collects all extra positional values and stores them inside a tuple. That is why star args is very useful when we do not know how many inputs will be given. The function sum_all uses star numbers to accept any number of values. Inside the function, we start with total equal to 0 and add each number one by one. This allows us to add 3 numbers, 4 numbers or even 100 numbers using the same function. When we add the 2 star double asterisk before a parameter name, Python collects all extra keyword arguments and stores them inside a dictionary. This is why double star kwargs is very useful when the number of named inputs is not fixed. Look at the example on the left side of the slide. The function accepts double asterisk my war. When we call the function with name, age and city, Python puts all these key value pairs into a dictionary called mywar. That is why the output shows the type as dictionary. We can access individual values using their keys, like mywar of the name should be mentioned inside. And we can also print all the data together. This approach is very useful in real applications where user information or configuration settings can change. Python allows us to combine all types of arguments in a single function. In Python, arguments must follow the order of first positional argument, then default argument, and then asterisk args, and finally double asterisk kwargs. In the function process_data, title is a positional argument. Version is the default argument with value 1.0. Asterisk args collects extra positional values into a tuple. Double asterisk kwargs collects keywords values into a dictionary. When we call the function, the title is passed first, then names like Emil and Tobias go into the args and details like age and city go into kwargs. We can also use asterisk and double asterisk while calling a function for unpacking arguments. Using asterisk, we unpack a list into positional arguments. Using double asterisk, we unpack a dictionary into keyword arguments. This makes Python function extremely flexible and powerful. Now let us understand an important concept in Python called scope. Scope means where a variable is available in a program. When a variable is created inside a function, it belongs only to that function. First, the variable x is created inside myfunc. So, when we print x inside the function, it works and prints the value. But if we try to print x outside the function, Python gives a name error. because x does not exist outside the function. Now let's look at nested scope on the right side. Here we have a function inside another function. The inner function can access variables created in the outer function. In myInnerFunc can also use the variable x defined in myfunc. This is called enclosing or nested scope. Now we are adding two specialist tools to our Python toolkit, lambda functions and recursions. A lambda function is a small function written in one line. It is used when the logic is very simple and writing a full def function feels unnecessary. The syntax is lambda arguments colon expression. Now look at the example. First we define a normal function called multiply. It takes two numbers a and b and returns their product. Next, we write the same logic using lambda. Lambda a comma b colon a asterisk b. Both functions do the same work. When we call multiply underscore lambda of 5 comma 6, the output is 30. Lambda function are best for short symbol calculations. Recursion means a function calls itself to solve a problem. It is useful when a problem can be divided into small similar problems like factorials. Every recursive function must have a base case. The base case stops the recursion and avoids an infinite loop. In the factorial example, if n is 0 or 1, we return 1. Otherwise, we return n asterisk factorial n minus 1. Calling factorial 5 gives the output 120. Use lambda for quick one-line functions. Use recursion for problems that repeat themselves naturally. Both are powerful tools when used correctly. Let us now have a quick summary on what we have covered in Python functions. It starts with the basics, how functions are defined using def, how they are called, and how they accept inputs. The difference between parameters, variables in the function definition, and arguments, values that are passed during the function call, is clearly explained. Next, it introduces the core argument types in Python: positional argument, keyword argument, and default argument. The slide then moves to the advanced function features. It explains how *args and *kwargs allows functions to accept a flexible number of inputs. Finally, it covers lambda functions for short operation and recursive function to avoid an infinite loop. So, let's open Jupyter Notebook and write some Python code together and bring the concept of Python function to practice. Thank you.